Hey guys, this is Einar. I hope you're doing great today and welcome to your 29th tutorial in Basic Statistics in Excel. Now in this tutorial we're going to talk about empirical probability distributions, and what we're going to do is we're going to simulate the throw of a dice and then we're going to put the results of the values that we get from each throw into this frequency table. And as you know, when you throw a dice you can get any value from 1, 2, 3, 4, 5 to 6. So that's what we're going to do. Then we're going to create a small diagram showing the probability distribution of getting different values on a dice that you're throwing. So let's get started. First we're going to decide how many times we're going to throw this dice. Well, 1000 is a common example because that's usually how many you have in a sample when you're conducting statistical studies. So I'm going to write 1, 2, and I'm going to pull these all the way down to 1002 because we start 2 rows down. So we need to go all the way down to 1002 in order to have 1000 numbers in a row like this. There we go, we have 1000 there at the end. Excellent. So now we know how many dice throws we have. Now how do you simulate the dice throw in Excel? Well, what you can do is you go equal to rand and then you go right between. And I write 1 there at the bottom and 6 at the top. Now what does this do? Well, it tells Excel to generate a random number between 1 to 6. So we tell Excel to do that and we pull it all the way down till our last dice throw. So we get a bunch of different numbers here, and these are dice throws. So you can see it's 1 in this throw, 4 in this throw, 5 in that throw, etc. So we move all the way back up again. Now if I increase the number of decimal points here, you can see it is integers, so it's not, there are no decimals in these. It's just giving us the discrete values between 1 and 6. So if we want to count the frequencies of the 5s and the 3s and the 4s and the 1s in this data set, we have to go into our frequency table here and write count if, so we're counting the number of occurrences in a data set based on a criteria. So what we begin is we select our data set like this, go all the way down. It's going to be far away down because we're throwing this dice a lot of times. So we're going all the way down here to 1000 and we have our data set selected. We add a comma and now we choose a criteria. Now I could write something, 1 or 2, whatever, but I'm going to choose my categories here, like that, and then close the parentheses. I fixed my data set because I don't want the data set to change. I always want my data set to be the same. So I put in $signs and I count it. Now you'll notice, I'm going to zoom in a bit. You'll notice when, if I select this again and I hit enter, the numbers here are changing. And the reason for this is that Excel is set to change all of these values every time I do something new. So we're always getting new random values when we've been using this function here that's called rand between. Even when I use the function itself, it changes the number. So these frequencies are going to change while we're working with the table. And because we fixed the data set here with $signs, all we can do is that we just put it down like this, and we get the different frequencies for the different values here. Now because I wanted to make this table look nice, it's going to look a bit screwed up when we do this, so we just select the whole thing, remove all the borders, and we put the borders back, and now it looks nice. Excellent. And in fact I'm going to remove the background color because it's going to screw it up for us once more. So this is just one of the things about Excel that it can be slightly annoying. But you go here to the paint bucket here. I happen to choose yellow now. You go to the paint bucket and you choose no fill, and then we're rid of that problem. We're going to write the total down here, and if we've done this correctly, this should equal to 1000 because we have 1000 dice throws. So no matter what these numbers are, our total is always going to be 1000. That means we're also ready to calculate the probability of getting a 1, a 2, a 3, or 4, or 5 when you're throwing a dice. So first we write equal to, we take the number of frequencies we have divided by the number of throws we have, and we get a share, which is 0.168. So in our empirical probability distribution, we get 0.168 chance of throwing a 1 when we're throwing a dice. And what we can do now is we double click this and we put a $sign here because we don't want the total to always stay the same. And you see it changed, but that's because the random numbers are being generated all the time. I pull it all the way down there, and as before we need to fix the slightly screwed up borders there. There we go. And we get our probabilities here. I might want to express these as percents, especially when I'm going to have them in a table later. So what I do is I take each number and I multiply it by 100. Now we don't have to fix 100 because it's a number, so it's never going to change. There we go. I have to fix the borders once more. There we go. Now, you might wonder, like, well, the chance of throwing a 1 to a 6 isn't gonna change. The dice has equal sides, so why are these probabilities different? Well, that is because we're using an empirical data set, so it's actually going to vary. But if I threw this dice like 1 million times or 10,000 times or something like that, we will actually get a probability. Now, I happen to know this because I've calculated it before. We will get a probability of 0.167. Now, if you wanted to calculate that yourself, you could just figure it out. Well, we have one dice throw, and we're going to divide that by the number of possible values we can get on a dice, which is 6, and I get 1.66666667, and if we round that up to 2 decimal points, we get 0.167. So this is the true or theoretical chance that should be that you're going to throw a certain value on a dice, but when you do it empirically, you're going to get a different result. And this is something that's very important in statistics, because we're always working with comparing theoretical probability distributions to empirical ones. But we're going to talk more about that later. Now we're just going to create a little bar chart that is going to show us our probability distribution. It looks like this. I'm going to zoom out a little bit. There we go. To begin with, it's going to look like this. And this, I think, is a very ugly bar chart, because to begin with, it isn't clear that we're talking about shares here that equal to 100%. So one way of doing this is selecting your y-axis and setting the maximum to a fixed value of 100. That's one way of doing it. And then it becomes more clear that, okay, this is 100%, and each of these shares all add up to 100%. And since these are dice throws from 1 to 6, I don't have to change to these category labels, but if I wanted to, I could do that. I would just go here, select data. Maybe you didn't see that. All right, go up here, there, select data, and here for the horizontal category axis labels, I'll choose edit, and I would choose my category labels. But since they are 1, 2, 6, it's not going to change. One little thing I could do is I could select these data series, choose to format them, and then fill them with vary them by point. But that's up to you if you want to do. I'm going to move it up here. See? So there's no more choices. You just vary it by point, and you get different colors for different bars. But this isn't, necessary. So basically, that's how you create an empirical probability distribution based on throwing a dice. Now, this is going to look different for different types of probability distributions, of course, but this is the general principle. We have our 0.167 probability, which is theoretical, of throwing a single value at a dice, because we know how many sides a dice has, and we know each value has one side. But when you do it in practice and you just throw the dice, you'll get different values. But in general, you'll see that these are located around 0.167. I think even if we counted the average, let's calculate the average just for fun. There we go, the average. And if I selected my shares there, yeah, I get 0.167. So that's it on theoretical and empirical probability distributions. I hope you have some fun just trying to throw the dice different number of times, and maybe try changing the results you can get, and have some fun. And I'll hope to see you in the next tutorial. I'll see you later. Bye bye.